Sawa. Nayo, sawa. Sawa. Twambie rĩu. Tuthiĩ rĩu. Tuthiĩ rĩu. Anjĩrĩria. This is sounds an introduction.
Now, good morning.
Morning.
Okay, welcome to our class for today. My name is Teacher Anthony. Now, today we are going to learn about electrochemistry. Subject, chemistry, right? Very good. So we're asking ourselves, what is electrochemistry? So we've been going through chemical reactions and so on. But today we want to learn about electrochemistry. So, what does electrochemistry entails? Electrochemistry is a topic that tries to examine how chemical reactions produce electrical energy. So we are learning today that chemical reactions produce what? Electrical energy. And that electrical energy is used to cause what? Chemical reactions. Okay? So it means that whenever a chemical reaction is taking place, we end up producing what you call what? Electrical energy. And this electrical energy causes chemical reactions. Now, these chemical reactions, whenever chemical reactions is taking place, it is all about transfer of electrons. Transfer of electrons. Now, somebody to tell us one characteristic of electrons, or where are electrons found? Where are electrons located? They are located in the energy level. That's very good. So we have a structure of an atom. So this is an atom. We have a structure of an atom. And we say that an atom has got how many regions? 2 regions, right? The first region is known as what? The nucleus. And the second region, energy level. Energy level. So what subatomic particles are found in the nucleus? Protons and neutrons. Very good. So we have protons and neutrons. What subatomic particles are found in the energy level? Electrons. Electrons. It is a reaction originating from the energy level. Because in the energy level we have what? Electrons. And the electrons have got which charge? Negative charge. So they have a negative charge. So electrons have got a negative charge. So today we are talking about chemical reactions, and chemical reactions are reactions originating from the energy level. And chemical reactions produces electrical energy. And electrical energy is going to cause what you call a chemical reactions. So in other words, chemical reactions, it's all about transfer of what? Electrons. Very good. Now, so electrochemistry is all about chemical reactions producing electron transfer. So electron transfer, and electrons are moving from one point of a reaction to another. So today we want to talk about what you call, let me erase this one. Then we talk about what you call redox reactions. Redox reactions. Redox reactions. Let's talk about redox reactions. Redox reactions. Now basically, electrochemistry is all about transfer of electrons during chemical reactions. So what are redox reactions? Or what is a redox reaction? So it's a reaction in which oxidation and reduction process, reduction and oxidation reaction occurring simultaneously. occurring simultaneously. So they occur simultaneously. So they occur simultaneously, and that is what we call a redox reaction. So there are two terminologies here. So we have oxidation and also we have reduction. So what do you mean by oxidation? What do you mean by oxidation? What's oxidation? Oxidation. What is oxidation process or oxidation reaction? Oxidation reaction talks about what? Loss of electrons. So we are talking about loss of electrons. We are talking about loss of electrons. So you find that a species in a reaction we lose an electron, and the loss of electrons we call it oxidation reaction. So oxidation reaction actually is, we talk about the loss of electrons. So that is oxidation reaction. So oxidation reaction is all about loss of electrons. Now let's talk about reduction. So let's talk about reduction reaction, reduction process. What is reduction process or reduction reaction? Yeah, so we talk about gain of electrons. We talk about gain of electrons. Okay, so when you're talking about reduction reactions, is where now oxidation and reduction taking place simultaneously. That is at the same time. So one of the species will lose an electron or electrons. The other species will gain that very electron. So oxidation and reduction taking place at the same time, we call that reaction what? Let's talk about reducing agent and oxidizing agent. Now let's talk about reducing agent. Demonstrate oxidation and reduction. In other words, redox reaction. Now, so we're going to ask ourselves a question. Now, the question is, what is observed when iron filings are added to copper 2 sulfate solution? What is observed? What is observed? What is observed when iron filings are added to copper 2 sulfate solution? So it's a question we are asking ourselves, and we just want to do a simple experiment to see what is observed when iron filings are added to copper 2 sulfate solution. Okay, so in this kind of a reaction, we are going to have what you call a displacement. So the metal ions, one of the metal ion is going to be displaced from the solution by a metal which is more reactive. Now, so the first thing you have to understand is the reactivity series. Reactivity series. You remember the reactivity series? Yes. So there is a formula that we use to come up with the elements in the reactivity series. Now, reactivity series. So we have to know first of all the reactivity series, then we'll get to the reaction. Now, reactivity series. Let's talk about reactivity series a bit. Then we come back to our practical reactivity series. So there's a formula we use. There is a formula that we use in order to list the elements in the reactivity series. So there's a formula that we use. We say what? Stop, please. Stop calling me a careless zebra. Instead, try learn how copper, mercury saves gold. Very good. We say, please. You say, it's like a begging, please. Stop. There's a time I was teaching somewhere, then I say, please stop calling me. Somebody was like, what? Have I called you a careless zebra? No. This is a formula. So please stop calling. Please stop calling me a careless zebra. Instead try, learn how copper, mercury saves gold. Saves gold. Okay? Now, so please stand for potassium. So the potassium is the most reactive element, by the way, in the reactivity series. So this is potassium. So it comes from a Latin name. It comes from a Latin name, kalium. That's where we get the chemical symbol, all right? So we have potassium, then we go to sodium, nice. Go to sodium. Then from sodium we go to calcium, that's good. Calcium. From calcium, magnesium, very good. So you've got to understand the reactivity series. Magnesium, sorry. This is magnesium. We have magnesium, followed by aluminium, that's good. Aluminium, carbon. So in the reactivity series we have this non-metal by the name carbon. So we have carbon. What is the chemical symbol for carbon? Capital letter C, correct. So zebra goes for zinc. What is the chemical symbol for zinc? Capital Z, small letter N. So this is zinc. Nice. Now instead goes for iron. Nice. So we have iron. Then this one goes for tin. We have tin. Then lead we go for lead. So we have lead. Then how we go for hydrogen. Then we have copper, mercury, silver. So we have silver. And finally gold. Very good. So these are lists of the reactivity series. We start from the most reactive to the least reactive. So which is the least reactive element here? Which is the least reactive? Gold is the least reactive. The most reactive? Potassium. Potassium is the most reactive. Very good. Now, let's get to our experiment. Our experiment for today, we are asking ourselves, what is observed when iron filings are added to copper 2 sulfate solution? What is observed? Now, so I'm going to call one of us, Beatrice, maybe come and help me. We just mix some chemicals here, then we proceed. Now, so I have copper here, so we have copper. So what is the color of copper 2 sulfate? So I'm going to make a solution of copper 2 sulfate. So what is the color of copper 2 sulfate when it is hydrated? When it is hydrated, what's the color of copper 2 sulfate? This is a blue salt. So this is copper 2 sulfate. We're just going to use a little of copper 2 sulfate. So it is blue in color. So it's blue in color. And very good. It is going to mix for us. Yeah, you know, standing here isn't a joke, my friend. So we have copper 2 sulfate. So she's going to add some water, then a stirring rod. So what is the name of this apparatus? Beaker. What is the color of hydrated copper 2 sulfate? Blue. It is blue. Okay. So when it is anhydrous, what is the color? When it is anhydrous, losing the water, when it loses the water of crystallization, so it comes to white, right? Yeah, so it changes to white. So she's going to add some water, approximately, let's say 200 cubic centimeters, 200 ml. Then she's going to stir using a stirring rod. Very good. Up to there is okay. Let me just add some more. Then she's going to start. Remember, we are making copper 2 sulfate solution. We're just doing it randomly. So we are making copper 2 sulfate solution. So she's stirring so that the copper 2 sulfate crystals can dissolve. Okay? Yeah, so we are making copper 2 sulfate solution, then we are going to add ion filings. So what is the color? What is the color of ion filings? So we have ion filings here, the particles of ion. So we call them the ion filings. So what's the color? No, others have actually have to rust. So the color is gray, right? Yeah, so she's going to add these ion filings in the solution after it has dissolved. Then we learn more about that, because we are asking ourselves what is observed when ion filings are added to copper 2 sulfate solution. What's observed when ion filings are added to copper 2 sulfate solution? Yeah, I can see now the solution is ready. Very good. Then she's going to add ion filings into the solution of copper 2 sulfate. Use maybe spatula, or you can just place them like that, no problem. So we're going to leave the experiment a little bit for the reaction to take place. And do you see any reaction taking place? Yes. So there's some bubbles being produced. Maybe you're going to add all of them. You're going to add all of them. Then you give it time. Give it time for the reaction to take place. Beatrice, do you observe anything taking place during the reaction, maybe as you lift? Yeah, so what are you seeing? You are seeing there's some effervescence, alright? Effervescence. Maybe you're going to place it like this so that it can be seen. So there's some effervescence being produced, so it means that the reaction is on. You see the effervescence? Yeah. So the reaction is still on. So Beatrice, what are you observing? She's scared, right? Yeah. So the reaction is on, and we can see some brown solid, formation of some brown solid. So are you seeing some brown solid being formed here? So the reaction is still on, but you're going to give it time a little bit. We're going to give it time. Then we're going to observe. So the reaction is still on, so we're going to give it time, but we can see some brown solid being formed. Now let's come, as the reaction is taking place, let's come to the reactivity series. Now, so we have copper 2 sulfate here, copper 2 sulfate in solution form. So let's identify the ions that are present in copper 2 sulfate. So what is the formula for copper 2 sulfate? Capital letter C, then we have U, then capital letter S, then we have capital letter O, then we have 4. So 4. That is copper 2 sulfate. Now when it is in solution form, the ions are free to move. So what are the ions present in copper 2 sulfate? The ions that are present, we have copper ions, copper 2 ions, and the copper 2 ions makes the solution to be blue. So we have copper 2 ions. Which ions are present here? The sulfate ions. We have the sulfate ions, SO4. So we have 2 ions in copper 2 sulfate solution. You know, when it is in solution form, the ions are free to move in the solution. They are very free to move in the solution. So we have copper 2 ions, and also we have sulfate ions. Alright? Now what is the formula for this element by the name ion? The ion, the metal itself. What's the formula? Capital F, small letter E. So it comes from a Latin name, ferrum. Alright? Now, between ion, metal, and copper, which one is more reactive than the other? between iron and copper from the reactivity series. Which element appears on top above the other in the reactivity series? Iron is more reactive than what? Than copper. So iron is more reactive than copper. So iron is more reactive than copper. So this is iron. It is above copper in the reactivity series. It is above copper in the reactivity series. So this is exactly what is going to happen. So when you put iron filings in copper 2 sulfate solution, the reaction is still on. We're going even to note the color of the solution. So when you put iron filings in copper 2 sulfate solution, iron being more reactive than copper metal, so iron is going to displace copper from the solution. When I say displacing copper from the solution, copper is in ionic form, so it is in form of an ion. So iron, the metal, when you put iron metal in this solution, the iron is going to take the place of copper. That is displacement. So more reactive element or more reactive metal will displace a least reactive metal from the solution. So iron will displace what? Copper from the solution, because iron is more reactive than what? Than copper. So the moment iron gets to the solution and becomes part of the solution, the iron will have to lose an electron. Because here it shows that copper already lost 2 electrons. That's why it is in what? It is in ion form. It is in solution. So copper had lost 2 electrons. That's why you find it in solution form, that is in ionic form. Now when iron gets into this solution, so it's going to take the place of copper. So the copper, in this case, will gain an electron and returns back to the atom form. So this is exactly what is going to happen here. Now let me take you through. So I'm saying, when copper, so this is the solution now. Let's say this is the beaker that we have here. Then you tell me the color of the solution. The reaction is still on. So you find that in this solution, we have copper 2 ions. That's why we call it a solution. So it is in the solution. So this is a metal in ionic form, so it is in the solution form. Then we have the sulfate ions. So when you put ion filings here, ion filings form, so it is not stable. For metals to be stable, they do what? Do they lose or gain electrons? Reactive than copper. So when iron gets to this solution, so it's going to lose it's going to lose 2 electrons in order to be in ionic form. So when iron gets into this solution, the iron will lose how many electrons? 2 electrons. Now the copper, remember, it had lost 2 electrons in order to be in ionic form. That is copper 2 ions. Now it's going to gain the 2 electrons now to return back to be called an atom or an element. Then the copper will gain the 2 electrons and copper will now be displaced from the solution. Now our solution will not have copper. Our solution now will have what? Ions. Now let's take a look at the reaction, the ionic equation that is taking place here. So we are having iron metal reacting. Now this is about displacement. So we're going only to list those elements, those species that are involved in the reaction. So we have copper 2 ions, which is in the solution. So we want to displace copper 2 ions from the solution. We want to displace copper 2 ions from the solution. That is a displacement kind of a reaction. Now, iron will lose 2 electrons. Then we are going to have what? Ion 2 ions. It's going to lose 2 electrons. Now, copper is going to gain those 2 electrons. Then we are going to displace it from the solution. We are not going to have copper 2 ions. We are not going to have copper 2 ions in this solution again. So we are going to have, so iron will lose 2 electrons. Ions will lose 2 electrons to become ions. Then copper will gain the 2 electrons and is going to be displaced from the solution, and our solution is not going to have ion 2. So we are going to have copper as a metal, which is in solid form. This is in solution form. Now it is in solution form. And on the reactant side, we had copper 2 ions, which is now in solution form. And the ion filings here, this is a solid. Now we see that ion has undergone which process? Oxidation. So this is oxidation process. Oxidation process or reaction. Loss of electrons. That is what we call oxidation. Now on the other hand, copper 2, the copper is in solution. That's why we're writing here AQ, aqueous. Then it's going to be displaced from the solution. Then the solution will no longer have copper 2 ions. But our solution will have which ion? Ion 2. Ion 2 now will be in the solution form. Copper 2 ions will no longer be in solution form, because that solution is known as copper 2 sulfate, whereby we have copper 2 ions and sulfate ions, but we want to displace copper 2 ions from the solution. So our solution will no longer have copper 2 ions, but our solution will have which ion? Ion 2. So the most reactive metal will displace the least reactive metal from the solution. So our solution will not have copper 2 ions, but at the end, our solution will have what? Ion 2 ions. So what do you call this process whereby the copper 2 ions gains back the electrons that it has lost earlier on? What do you call that reaction? Reduction. So these are reduction process. A reduction reaction. Right? So do we have now in the product now? Do we have ion 2 ions in the solution? Do we have ion 2 ions in the solution? Yes. Now just check. Do we have ion 2 ions in the solution? Ion 2 ions in the solution? Yes. Yes. How about copper 2 ions? No. It has gained 2 electrons. Now it has changed from now being a solution. Now it is no longer in a solution, then we are going to have a solid. Now the reaction is still on. Then one of us is going to tell us what is observed during these reactions. The reaction is staying on. One of us is going to tell us now what is the color of the solution, because we are asking ourselves what is observed when ion 2 ions are combined with copper 2 sulfate solution. What is observed? Now let's identify the reducing agent. Let's identify the reducing agent. Let's identify the reducing agent. So, what is a reducing agent? What is a reducing agent? A reducing agent is that species that does what? Lose electrons. Species, we are talking about a species that lose electrons. Species that lose electrons actually is a reducing agent. Now, in our ionic equation, so which species is a reducing agent? Which species actually is a reducing agent here? The ion. Ion is a reducing agent, right? Yes. So ion here is a reducing agent. So a reducing agent normally undergoes a process by the name oxidation. A reducing agent is that species now that lose an oxidation. Now, let's talk about an oxidizing agent. Oxidizing agent. Oxidizing agent. Oxidizing agent. So, what is an oxidizing agent? What's an oxidizing agent? A species, we talk about a species that gains electrons. So which species gains electrons? Which species gains electrons? Copper 2 ions. Okay? Copper 2 ions. So it gains electrons from copper 2 ions to copper metal. So copper 2 ions actually is our oxidizing agent. Copper 2 ions is our oxidizing agent. Sorry? Yeah. So you can just pick it from the reactant side. So that is it. So copper 2 ions is our oxidizing agent. Undergoes which process? Undergoes which process? Reaction. Very good. Okay. So between copper and iron, which one is more reactive than the other? Iron is more reactive. That's why it's capable of displacing, removing copper 2 ions from the solution, aqueous, from the solution. Now it is in which state? Solid. So it has been displaced. That is a displacement kind of a reaction. So it has been displaced. Imekuwa displaced immediately. Imekuwa displaced. So the most reactive species or element or a metal will displace the least reactive metal from the solution. Yes? Copper 2 sulfate. That's a solution that contains the ions, the copper 2 ions and the sulfate ions. So here we are talking about a reduction and oxidation process based on the metals. Alright? So in this solution, we are just checking which metal is going to displace the other from the solution. Alright? From the solution of what? Copper 2 sulfate. From the solution of copper 2 sulfate. Now, maybe one volunteer to come and tell us the color of the solution and the color of the solids that are obtained here. One of us, maybe to come and tell us the color of the solution and the solid that are observed. You come? Yeah, just come and tell us. Yeah. Green. Yeah, just. Okay, solution. The solution now. What's the color of the solution?
Green.
Yeah, so the color of the solution is green, alright? So the color of the solution is green. So it changed from blue now to what? To green. Okay? So green, okay? We have a pale green solution. So it's pale green solution. Okay, the color is green, the solution is green. You know it changed from blue to now what? Green. Now, the reason as to why we had the blue solution at the beginning, the reason as to why we had the blue solution at the beginning, it was because of which ion? Ion 2 ions. It was because of ion 2 ions. That's why the solution was blue at the beginning. Now, ion 2 ion has been displaced from the solution. So we no longer have ion 2 ions. That's why the color is no longer blue. We no longer have ion 2 ions in this solution. It has been displaced. Now the solution is pale green. We're having a green solution. The green solution is because of the ion 2 ions, which is now part of the solution. The pale green solution is because of which metal ion? Ion 2 ions. Alright? It's because of ion 2 ions. Now, the blue solution initially was because of which ion? Copper 2 ions. But copper 2 ions has now been done what? Displaced. Now we no longer have the blue solution. We have the green solution, and the green solution is because of what? Ion 2 ions. Now there is also another solid that can be observed here. Maybe somebody else to tell us the color of the solid that is here. Then there are two observations that we're going to make here. Now, wacha tuambiwe na rafiki yetu, what is the color of the solid here? Chariot. Very good. The color of the solid, the color. Brown. Okay? So we have brown solids. Right? So we have brown solids here. So I'm going to bring it round. So we have brown solids. Okay? So we have brown solid. Are you saying? Brown solid. Today we were just doing the demonstration, right? So we have brown solid. We have blue solution and brown solid. You see? Brown solid. Brown solid. You see brown solid? Exactly. You see that? Brown solid. Brown solid.
What is cool?
That's it. Yeah. So we are having brown solid. Very good. Very good. So we're having brown solid and that's it. Okay, class? We're having brown solid. Wow, so that's powerful. Brown solid. That's good. That's good. That's good. That's good. That's good. Now let's make the observations now. Let's make the observations. That's good.
My lawyers.
Now let's make the observations. So who can tell us about the observations that we made during the reaction? The observations made. Who can tell us about the observations that we've made during the reaction? Observations made. Observations. Just want one volunteer to tell us. So you find that the blue solution of copper 2 sulfate, copper 2 sulfate changes to what? To pale blue. Pale green. Thank you. Pale green. Right? Blue solution of copper 2 sulfate changes to pale green. Okay? Then what else do we observe? What else do we observe in the solution, in the beaker? Brown solid, which is copper metal, is formed. Brown solid, which is copper metal. Brown solid, which is copper metal, is formed. Brown solid, which is copper metal, is formed. Brown solid, which is copper metal, is formed. Because in our solution, the iron 2 ions now displaced. The iron 2 ions now took the place of copper 2 ions. The iron 2 ions took the place of copper 2 ions simply because iron is more reactive than copper. So ions appears above copper in the reactivity series. So that is it. Now we can have half ionic equation. We can have half ionic equation for each. Half ionic equation. We can have half ionic equation for each. Half ionic equation for each. So we can have half ionic equation for each. Now formation of copper metal and also formation of iron 2 ions in the solution. So iron 2 ions. So whenever you have two ions in a solution, so it will display a green color. The solution will display a green color. So half ionic equation. So let's talk about half ionic equation. Now, so we can talk about half ionic equation for ion. Let's begin with ion. So ion reacted by doing what? Ion reacted by, is it gaining or losing? Losing. So you put an arrow immediately. Losing electrons. So it lost how many electrons? 2 electrons to form what? Ion, 2 ions. Then you show the number of electrons that it actually lost. Alright? So this one is in which state? Solid. Then after dissolving, then changes to aqueous now. Right? So what process is this? This half ionic equation represents which process? Losing of electrons, which we call it what? Oxidation. So that's an oxidation process. Right? So this is a half ionic equation for the formation of ion 2 ions in the solution. So half ionic equation for the formation of ion 2 ions in the solution. In the solution. So check very well on the state symbol. So this is solid, this is aqueous. It means that it is in solution. What do you call this process? Is it oxidation or reduction? Remember, it is gaining. It is a reduction process. Reduction. So these are reduction process. Transferred from one species to another. That is basically about electrochemistry. Transfer of electrons from one species to another.